Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Module 17, Building a Small Network. Now that we've gone through all of the different modules, you should have a basic understanding of how networks communicate. So we should be able to build a small network now. What we're going to be discussing in this module is talking about the devices in a small network, application and protocols used in that small network, the scalability, how we can verify connectivity. We're going to look at some of the basic host and iOS commands to acquire information from devices on the network. We're going to be talking about troubleshooting methodologies and troubleshooting scenarios. So we actually have a lot to cover in this module. So let's go ahead and dive right on in. First section is devices in a small network. The majority of businesses are small to medium businesses. That means they have limited budget. They cannot always afford the most expensive or best products. For example, a corporate environment may be able to justify spending $5,000 for a switch, where a mom and pop store, that's not their budget. That's way outside what they're realistically capable of spending. So we have to get things that are appropriate for their size. A small to medium network are typically simpler in design, management, and security because of that cost portion of the project or the network design. Normally, small networks have like a DSL or cable broadband type connection. They may not have a straight fiber connection or Metro Ethernet or MPLS type connection because of, again, costs. Network management is also a concern. Small businesses don't have the budget to have a network engineer, a network architect, a security engineer as well. So again, smaller companies normally contract these services out to third parties. So when we're looking at device selection, cost is going to be a huge part of the overall equation. Speed and topology are also there. Scalability, future-proofing, functionality are all factors when looking at what devices should be there. Cost probably being the most important. When we're talking addresses, we have to look at the number of hosts, the number of peripherals, the number of servers, and if there's intermediate devices that are connecting everything, are those addressable? Are we talking additional IoT-based devices, camera devices, smart devices? Well, we have to plan on everything that needs an IP address having an address within our addressing scheme. What about redundancy in a small network? A small network typically cannot afford the massive redundant connections that a larger business may have. A small business may not be able to afford backup internets or 2 core switches or multiple servers that are there just in case one fell. Small networks may have 1 router, 1 switch, 1 server, and that is the best that they can do. Redundancy, while it is important, is often very costly. So in order to maintain a high degree of reliability, redundancy is required. The redundancy helps eliminate a single point of failure, but you also have to factor likelihood of failure and cost into the equation. You also have to look at managing the traffic. If there's mass amounts of traffic on the network, we may have to implement a technology for actually prioritizing the traffic. That would be quality of service. The priority queuing has 4 main queues. High priority is always emptied first. High, medium, normal, low priority are the 4 main queues. High priority is going to be anything that must be sent first that has a real-time component. Everything else can be classified other ways. And that way you can prioritize what is important and what's not important. So looking at a small network within the application and in the protocols, the network applications are going to be things operating at the network and the lower level layers. That means the software we're looking at needs to be able to understand the application layers, where the higher layers, layers 4, 5, 6, and 7, are going to be the application layers. This is not going to look at the network aspect of it. So application services don't care about the network application functions. They operate assuming the network is going to be there and stable. Protocols, like we've talked in previous sections, protocols like HTTP or HTTPS or FTP, DHCP, and DNS, these are all common protocols that will be in a large and small network. It doesn't matter the size of the network. These are all core services that a network typically runs off of. Essentially, these protocols allow for the overall structure of the network. So that means syntax of messages, that means the types of messages, the expectation for sending and receiving messages. That's the purpose of these protocols. So when you look at a small network and what protocols should be running, essentially you can think of the guidelines that the network is going to be using. If we're looking at voice and application services, these are going to be things that ensure that there's a certain level of infrastructure that's there. Is the network design capable of handling that voice and video functionality? Is VoIP going to be there? Are end devices using telephones or soft phones going to be there? Do we have latency issues, or do we have to implement some form of quality of service or real-time transfer protocols? What things have to be there to ensure that the infrastructure we need to support those applications are really there? And part of that all brings up the scalability, or the ability to scale the network to grow as the company or organization implements newer technologies. The next section is scale the large networks. Again, networks grow, and so that means the networks have to be able to be scalable. How do we ensure that networks can scale? 4 main areas: documentation of the way the network is set up, configured, structured, both physically and logically. Inventory. What devices are there? What model numbers are they? What ports, what speeds, age of the equipment. All of that needs to be there. That way, we can grow accordingly. Basically, if we have a core switch and it's 10 years old and it only has 10100 megabit speeds, and we're trying to implement a new gigabit infrastructure, the inventory list will tell us, hey, we bought this switch 10 years ago. These are the functionality or the features of the switch. Maybe use this for justification for buying a new switch. With any type of growth, there's a budget. We have to make sure we can afford it, and it's actually going to help generate funds, because again, the purpose of a business is to make money. So having to spend money to ensure the network can grow then allows other portions of the organization then to be more effective and efficient. That helps generate funds. So budget is overly important. The last thing is traffic analysis. We need to understand what services have to be running, what applications have to be running, and what does that traffic look like. These 4 key areas basically allow us to make decisions on how the network can grow. The traffic analysis is not just about traffic, it's also looking at the protocols that are running, because in order to determine the traffic flow patterns, we have to look at what protocols, what services are actually running. That way we can get a realistic understanding of how the network is flowing. And that means performance as well, not just information. All of these allow us to get a bigger picture of how the network is operating. So if we try to implement additional services or an additional devices, this will tell us the impact that it may have on the current network. So let's look at employee network utilization. What utilization does an employee have on the network? That means OS versions, updates, services, feature sets, vulnerabilities, all of those go into play when we're looking at what that device will have on the impact on the network. So all of this allows us to get a baseline of the network, to capture what the network is doing at a certain point. That's called a snapshot. When we're looking at utilization, we may also want to look at device utilization, CPU, memory, storage, things of that nature. That way we can see what it was now as opposed to what it is after upgrades. That way we can see a comparison. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.